Hi, in this video I'm going to demonstrate the working of a Twitter application using sockets for peer-to-peer communication. In this application we have a central server which we will call tracker, and we'll have several client processes, each which denote a user for our application. Since it uses sockets, we need to register the port number and the IP address on which the user is running, so that each user can fetch those details from our tracker process and send messages to each other. To start a client process, we need to specify its port number and the IP address on which it is running, and we'll store those details on our tracker process. When we start our user process, we need to assign a handle to the user which will denote its unique identity on our Twitter application. So let's give it a name. So as you can see, we have completed our first command, which is registered. So our tracker process receives this payload from our client process, which says that the type of request is registered, the IP address and the port on which the response is to be made is specified over here, and the details of the message or the payload itself is in the data field, which says that the handle to be registered is user1. The IP address on which the user process is running is this. We assign two ports, one to receive message and one to send message, which is specified over here. And since it's a new user, we don't have any followers, neither does it follow anyone, so we have two empty lists. Let's now start another client. As you can see, we have started 3 client processes with the name user1, 2 and 3. Now let's see what happens when we reuse a handle name. So now when we registered using the same name as we have earlier, the tracker sends an error response to our client. The status for this message is 3, denoting error. The type of request is registered, and the message says that the handle already exists. So we need to give a unique handle name for this user process. Now as you can see, we have registered the new client using a unique handle name user4. Now to fetch the details of all the users that are currently registered on our application, we issue a query handles command. First, the tracker process receives a request saying that the type is query handles, and the process requesting it is waiting to hear the response back on this IP address and on this port. On the side of our client, we see that when we issue the query handles command, the tracker responses with a status 1 denoting success, type query handles, and gives a count of 4, which denotes the number of users that are currently registered, and the data for those 4 users are over here, as you can see. Next, we want users to follow each other, so let's make some users follow each other. So from user 2, we'll try to follow user 1. So we need to store this information in our tracker process. So when we follow user 1 from user 2, it sends a request to tracker saying that the type is follow. The name of user which wants to follow is user 2, and it needs to follow user 1. Since user 2 does not follow user 1, and since user 1 exists, it responds a success response saying that the user 2 is now following user 1. If we try to follow a user which does not exist in our database, it should give an error. So as you can see over here, when the user 2 tries to follow a user with the handle name user6, it sends an error response saying that handle user6 does not exist. Let's now make other users also follow user 1. Now, when we perform the query handles command, we need to get the updated information from the server. Now, when we do the query handles command, we see that the user 1 has 3 followers, that is user 2, user 3 and user 4. And for each of those users, we can see that they are following user 1. We can also drop or unfollow users. So when we issue this command, it will update the tracker that user 2 does not want to follow user 1 anymore. We see that the tracker has received a request saying that the type is drop and that the user 2 wants to drop or unfollow user 1. The server gives an successful response saying status 1 and with the message saying that user 2 is now not following user 1. Now let's verify if this is stored correctly in our database on the tracker. We see that in the updated information, user 1 only has 2 followers now, user 3 and user 4. It does not follow anyone, and user 3 only follows user 1 and user 4 follows user 1. Let's follow user 1 again. Now let's go on to tweeting a message. Since we have 3 users that follow user 1, when user 1 issues a tweet, all of the user 2, 3 and 4 should receive that tweet from user 1. To implement this logic, we need to make several design choices, which I'll explain as we go ahead. First of all, the user 1 will issue a tweet command. Now let me explain to you what has happened in this process. When the user 1 issues a tweet command, the server receives that request saying that the handle user 1 needs to tweet, and the server responds back to user 1 with the list of its followers. So you can see that the user 1 has received a message saying that it has 3 followers, and the details of those followers are sorted alphabetically. Now, on receiving this information from the tracker process, the user 1 will send a message to each of its user with the data of their left and right neighbor in the chain. So it sends 3 requests to user 2, 3 and 4 respectively, telling them that their left and right neighbors. So user 2 will receive a message from user 1 saying that its left neighbor is user 1 and right neighbor is user 3. User 3 will receive a message saying that its left user is user 2 and right user is user 4. And the user 4 will receive a message saying its left neighbor is user 3 and right neighbor is user 5. User 1. So now we have set up a circular link in our application when user 1 wants to tweet any message. As you can see, first user 2 will receive a setup message from user 1, and the data inside it has its left neighbor and its right neighbor. Similarly, user 3 receives a message saying that user 2 is the left neighbor and user 4 is the right neighbor, and user 4 receives a message saying that its left neighbor is user 3 and right neighbor is user 1, going back to the chain. Now once this state information is stored by each of these users, user 1 sends a propagate tweet message to its right neighbor. So you can see here that user 2 has first received a message from user 1 saying that user 1 has tweeted. After receiving this message, user 2 will send this message to its right neighbor, that is user 3, and the user 3 has received a message from user 2 saying that user 1 has tweeted. It goes ahead to user 4, which receives it from user 3, and then it forwards back to user 1. As you can see, user 1 has received a message from user 4, and since it was the user that had issued this command, it sends a update to the tracker saying that the tweet is successfully completed, and the tracker responds back with the success message and then is back to listen to other requests from the users. Now let's see what happens when we drop one of the followers and then issue the tweet again. So now we have made user 3 unfollow user 1. So now when user 1 tweets something, it should only go to user 2 and user 4. As you can see, user 2 has received the message, and user 4 has now received a message from user 2. Since the user 1 has updated user 4 saying that its new left neighbor is user 2 and its new right neighbor is user 1. So every time a user wants to tweet, it updates the state information in all of its followers. So the logical ring is complete and the tweet propagates through that logical ring. I have added a delay in sending these messages so that we can see the flow of messages across each users and their sequence. Now the only thing left is to exit the application. So what happens when user 2 exits the application? Let us see. The server receives an exit message from user 2 saying that it needs to leave the application, so it needs to delete all of the information that user 2 had saved on the tracker. We can see that the user has successfully deleted, and let's verify it with our query handles command. Now when we perform the query handle command, we see that when user 2 left the application, it was removed from the followers list of user 1, as well as its entire information is also removed from our application. Now when user 1 needs to tweet again, it should go to user 3 and user 4. As you can see, the message propagates first to user 3, then user 4, back to user 1, update the tracker, and end of tweet. Let's exit each user and see what the final result is. So now user 3 and 4 have exited. Now the only user left is user 1, and it does not follow anyone or is not followed by anyone. Thank you.